All right, this is the bell work. You're doing this right now. Put this in your notes. Find the percent composition of these two things. So this is from the quiz. You should have no problem doing this. You may need a periodic table, but this is what we're going to start with today. Anybody get CH4 yet? What'd you find out?
75% carbon and 25% hydrogen.
What'd you get for the other one? How can that be? It's the same ratio. Are they the same compound?
No.
Are these the same compounds? CH4 and C3H12, are those the same thing? Would they have the same properties? Would they have the same color or solubility or whatever, right? No, these are different things. But how on earth can they have the exact same percent composition, though? How's that possible?
The same ratio of them?
Yeah, these are the same ratio. What we learned yesterday, empirical formula, what was the definition of that? Look on your notes. Simplest ratio of atoms in a compound. This is important. This is a key concept. What we learned yesterday, empirical formula, right, was going backwards. This was forwards, we learned last week. Yesterday we learned to go backwards from a percent to an empirical formula. But there would be no way to distinguish, to identify which actual compound we're talking about here. All right? Problem number 1 on your homework. Get out your homework. Should look familiar. Right? What was your answer for number 1 on the homework? CH4. It was this. Right? That's because empirical formula only gives you that lowest ratio. What we learned today is molecular formula. And this is how we can actually distinguish which of these two things we're talking about. But you need to add a piece of data to the question. You can't just say, hey, I got something that's 75% carbon and 25% hydrogen. What exactly is this compound? You actually do not know. You don't have enough information to tell you that. What additional piece of information would be helpful here to distinguish between these two things? Something else we've learned in this unit that would help you distinguish between these two. What would be different? Molar mass. Molar mass is going to be different. What's the molar mass going to be here? 12 plus 4, 16, right? And then what's this one going to be? What do you notice about these two numbers, 16 and 48? One is exactly 3 times larger, right? Which again, that all makes sense. Okay, as we get into what molar mass, or I'm sorry, what molecular mass actually is, not this. We already did empirical formula. What am I doing here? What direction are we going here? Make a space in your notes for what molecular formula is. You need empirical formula to get here, and we're going to talk about how we use that. But just like we just saw, C3H12 was simply triple CH4. It was a whole number multiple of that empirical formula. I received some feedback yesterday that, wow, this is really empirical formula stuff. This is kind of easy, right? It's just some math steps that you have to follow to get you to the right answer. This is simply one more of those, where now you get a little additional piece of information on the problem, and that allows you to solve this. So empirical formula, again, is that lowest ratio. Molecular formula is just some multiple of that. That's it. We're going to do an example here in just a second. I didn't. I haven't graded all of them yet. So let's do an example.
Do 2 bucks of assignments and we study. Give a test next time.
So I have a compound that is 46.68% nitrogen. Whatever the opposite of that is, 53.32 oxygen. My target has a molar mass of 60 grams per mole. What is the molecular formula of this compound? It is 46.68% nitrogen, 53.32% oxygen, and it has a molar mass of 60 grams per mole. You're going to start by finding the empirical formula. If you look at your definition of molecular formula, you need empirical formula first. So follow our steps from yesterday. Let's get our empirical formula for this compound. You're doing this now in your notes. Step 1 of empirical formula is what? Convert to grams. And then divide by the molar mass of the element, or whatever it is. What's our next step? Is my math not right, Henry?
Oh, no, I just didn't see that you put the 68. That was off of this one.
So what does this tell us about our empirical formula? It's just NO. NO. Nitrogen and 1 oxygen. Okay, so let's think back to how we did this earlier with CH4. What do we need to solve next? What do we need? What other number do we need? The molar mass of our empirical formula. So the molar mass of NO is 30.
So the NO2, right?
No?
I know, you have to double it.
What is our molecular formula for our mystery compound? So look, our molecular mass, or I'm sorry, our molar mass of our empirical formula is 30 grams per mole, right? Our target has a molar mass of 60. So it must just be double our empirical formula, N2O2.
Can we not put NO with like,
No, because this is a molecular, this is a compound, right?
I don't know.
This is some kind of compound. If we wrote a compound, if we wrote H2SO4, right, we have the little numbers. H with a little 2, SO4 with a little 4. Right? So we are writing the formula for some compound. That is why it's this and not like this. It's not a coefficient. It's not this. We're actually doubling or tripling or quadrupling or whatever it is the number of atoms in that molecule. Empirical formula tells us the ratio. Molecular formula tells us what we multiply that by in our compound to get our actual ultimate answer. Just like we did up here. Right? These are two different compounds. This one is triple the molar mass, right? Because it's C3H12. Not something like this. We're not doing this. That's a different thing. That's just 3 of these. This is not 3 of those. This is a whole different molecule. That's what we're solving for here. Oops. Does this make any sense? Remember, the trick is empirical formula only gets us so far. It only gets us the ratio. We really still don't know what that molecule is or what that compound is. Empirical formula just tells us the ratio of the compounds to each other. That's it. That's all we get with empirical formula, which is still useful, to be sure. But if we really want to know exactly what that compound is, what that molecule is, we need to do a further step, and we need to know the molar mass of that eventual compound. Oh, get out your homework. Flip to page 2. Today we're going to do page 2. Start with number 1. Now, number 1 gives you a head start. How would we solve number 1? Find the molar mass of our empirical formula. Which is what? You should be able to do this on your own. Thank you. So what's our molar mass of our empirical formula?
Wow.
So what multiple is 92 of 46? Double. So what is our Target compound? Right? It's just a multiple of the empirical formula. It's just rounding error. So this one was probably 42.0, 40.0 something. It's just rounding error. Yeah, just use those numbers. It's fine. Maybe the 7 was rounded up, and the 5 was rounded down, and the 0 really isn't 0. It's 0.5 or something. Do number 2 on your own. That's correct. We're going to go over that together in just a minute, so good job. Do number 2 on your own. Yes. Good. Yeah, I think those are all right. What'd you do?
No.
Okay.
Yeah.
Good. Good. All right. Most of you have identified number 2. What is the compound? C5H10. Very, very good. All right. I have an interesting one for us. No, wrong button. How would you do number 1 here? In your notes, make a little space. And do number 1. You can kind of jot down what it says and see if you can figure out number 1. We haven't had a problem exactly like this yet. This is a little bit different, just in its wording. So what is missing from this problem that we've had in all the other ones so far? Percentages. We do not have percentages here. Okay? In all of the other percentage problems, we started by changing the percent to grams. Okay? This shortcuts that first step, and it just moves us right into grams. Percent is just a shortcut way of saying, well, if you have percent, we kind of assume you have 100 grams. That just lets us change the percent to grams. In this case, it literally just gives you the grams. So you can start right with that step. So you can say, all right, I have carbon and I have hydrogen. I have 49.98 grams of that and 10.47 grams of that. And you skip right to the divide by step. There is no percent to convert. You already have the mass. By 12, divide by 1. So what is our empirical formula here? You said that? Again, this is just our empirical formula, right? So are we done? Because you can't have CH 2.5. That can't be a thing. So you get a whole number. Bless you. So you can't have this. So you have to multiply this times 2 to get it to a whole number, C2H5. So what's our next step here? Well, true, but we have to figure out molar mass to figure that out. So this is 12 times 2, 24 plus 5, 29. And then our target compound is up here, right? The molar mass of our target compound is 58 point something. We found our molar mass to be 29, so what is our answer here?
2.
C4H10. I know this is messy because it doesn't give me enough room to write in here. You guys have more room in your book. Remember, molecular formula is typically a whole number multiple of your empirical formula. So this would be C4H10. All right, let's switch gears for a moment. So wrap up whatever you're doing. If you're working on a problem, if whatever, I want you at a stopping point. I want you to get out your homework and turn to the front page. Go down to number 6. Number 6. Now, this one should have looked a little different. What was different about number 6? H2O. It listed water. In fact, it even has oxygen listed separately. Why didn't it list some extra oxygen and hydrogen separately? Why do you think? Because it is a hydrate. And the water is its own thing. So when we go to do the empirical formula for this, we're going to convert to grams, right? 25.7 and 36.1. And then when we divide out, you're going to use 18 as your molar mass for water. Oh, it's copper.
Yeah, copper. Yeah, that's what I was 63.5.
Thank goodness you're here, Henry. What is it, 63.5?
Yes.
Okay. So now we do these. What do we get? What is it?
0.39.
I got 0.4, yeah.
That's my fault. I was
0.34?
No, 0.39 or 0.4. Whatever.
just do 0.4.
0.4, 0.4. This one's going to be 1.6, and this will probably be 2.0. Divided by 0.4, divided by 0.4, divided by 0.4, divided by 0.4. 1, 1, 4, and 5. And now the other stretch here would be to realize how you need to write this compound. What is this compound going to look like?
That's a compound times hydrate.
Times 5.
Right? Some of you, I know I saw in some papers, had this written a little different where you had like a this and a 5 or something weird. Remember, this is a hydrate. This is how we would list this. And your hint here was that water was listed separately as a percentage. So let's take this a bit further, because we're going to need this for tomorrow's lab. If I had 100 grams of this substance, how many grams of water do I have? 36.1 grams, right? 36% of whatever that sample is by weight is water. Right? Does that follow? Yeah. Let's play make-believe. I take that 100-gram sample of this and I put it on the stove. And I heat up that substance to where the water will essentially not boil off, but boil off. The water will evaporate out of this substance. And then I reweigh it after I heat that all off. What would my mass be? Started with 100 grams of this. How much would I have left if I cooked off all the water? 63.9 grams. How did you figure that out? Yeah, so we started with 100. 36% of that is water, and I heated it up to get rid of the water. And all I'm left with, right, would be this. The water disappeared into the air. Tomorrow in lab, we are going to actually do this. Okay? Where we are going to heat a hydrate, not this one. We're going to heat a hydrate and see if we can actually measure this and calculate this based on percentages and based on masses, which is something we've been doing this week. We should be able to do that math. Okay? You will be in pairs tomorrow. I'm going to give you the lab write-up today. On page 2 of that lab write-up is a sample. Okay? Not of what we're going to do, but of some made-up data from a lab that you would be able to measure, right? The mass before, the mass after, that sort of thing. You and your partner need to figure out how to solve that one and show me the data before you can start lab tomorrow. We have plenty of time to do that today. So you guys can snag your lab partners, whoever that is. You guys can figure it out. We're working in pairs. Who are we missing today? Just Ben? Okay, so he'll have to fend for himself tomorrow. But that is what you guys will figure out today, is that second page. For homework, finish also the second page of that homework packet from yesterday. I saw most of you are, if not done, or almost done already today. Okay? Questions? All right, Helgeson.